There are so many amazing railway structures around the world. Today we're talking about bridges and we've picked 10 of the most impressive ones. Now we must admit this list is pretty subjective. We chose the bridges that we as a team found the most exciting. They stood out because of their engineering complexity and the simple fact that we'd love to see them in person. These are the kinds of bridges that make you stop and say, wow. We also want to hear from you. Let us know in the comments if you'd rank these bridges differently or if there's one you think we missed. We will do our best to explain the design and unique features of each bridge as we go through the video. Let's kick off our list at number 10 with the Chenab Bridge. Known as the world's highest railway bridge, it is located between Bakal and Kauri in India. This remarkable steel and concrete arch bridge carries a single-track railway line over the Chenab River. An arch bridge is a type of bridge where the main load is carried through a curved arch, which transfers the weight horizontally to the supports at either end. The Chenab Bridge stands at an incredible height of 359 meters above the riverbed, making it not only the highest railway bridge but also the highest arch bridge in the world. It spans a total length of 1,315 meters, including a 650-meter viaduct on its northern side. Its massive arch stretches 467 meters and has an overall length of 480 meters. Construction began in the early 2000s but faced significant delays due to concerns over stability and safety. Work was halted in 2008 but resumed in 2010, with the completion date pushed to 2015. Ultimately, the bridge was fully completed and inaugurated in 2022, and the first full trial train run was conducted in June 2024. At number 9, we have the Tsing Ma Bridge in Hong Kong. Named after the two islands it connects, Tsing Yi and Ma Wan, this impressive structure is the largest suspension bridge in the world, designed to carry both road and rail traffic. Suspension bridges like the Tsing Ma Bridge are characterized by their deck being hung below cables that are suspended between tall towers and anchored securely at both ends. These cables bear most of the load, distributing it efficiently to the towers and anchors. This design makes suspension bridges ideal for long spans over water or other challenging terrains. The Tsing Ma Bridge features a main span of 1,377 meters and stands 206 meters tall. Its 41-meter wide deck accommodates 6 lanes of road traffic on the upper level. The lower level includes 2 railway tracks along with 2 sheltered carriageways, which are used for maintenance or as backup lanes during severe typhoons when the upper deck is closed. Construction of the bridge began in 1992 and was completed in 1997, taking 5 years to build. At number 8 we have the Great Belt Bridge, also known as the Great Belt Fixed Link, an impressive engineering achievement that connects the Danish islands of Zealand and Funen. This structure is not a single bridge but a combination of 3 major elements: a suspension bridge, a box girder bridge, and a tunnel. The West Bridge, located between Funen and the island of Sprogu, consists of 2 parallel bridges, one for road traffic and the other for rail. Completed in 1994, the West Bridge spans 6,611 meters and is supported by 62 piers. The Northern Bridge carries rail traffic, while the Southern Bridge is dedicated to road traffic. The bridge deck provides a vertical clearance of 18 meters, allowing smaller ships to pass underneath. From the island of Sprogu, the connection continues in 2 directions: the East Bridge for road traffic and the East Tunnel for rail traffic. The East Bridge, completed in 1998, is a suspension bridge that spans 6,790 meters between Sprogu and Zealand. It features a main span of 1,624 meters, making it the 3rd longest suspension bridge span in the world. Its 2 pylons, towering 254 meters high, are the tallest structures in Denmark. The East Bridge is designed exclusively for road traffic and provides ample clearance for larger ships to pass beneath its central span. The East Tunnel, on the other hand, is a rail tunnel stretching over 8 kilometers from Sprogø to Zealand. This makes it the second longest bored tunnel in Europe, surpassed only by the Channel Tunnel between France and England. At number 7 we have the Husutong Yangtze River Bridge in Jiangsu in China. This incredible structure is a combined rail and road bridge and holds the title of the easternmost railway crossing over the Yangtze River. Construction of the bridge began in 2014 and it officially opened in 2020. The bridge has 2 levels. The upper level carries a 6-lane highway for the S19 Nantong-Wuxi Expressway, while the lower level features 4 railway tracks designed for speeds of up to 200 km per hour. These tracks are part of the Husutong Railway, with plans to integrate the future Tongsujiayong high-speed railway. The main feature of the bridge is its cable-stayed span, which stretches 1,092 meters and is supported by 2 massive towers standing 330 meters tall. There's also a secondary arch span measuring 336 meters. A cable-stayed bridge is a type of bridge where the deck is directly supported by cables attached to tall towers. The cables are arranged in a fan-like or harp-like pattern, transferring the weight of the deck to the towers which bear the load. At number 6 we have the Crimean Bridge, the longest bridge in Europe. We've already published a detailed video about this bridge a few years ago, so if you're curious, be sure to check that out. The Crimean Bridge spans the Kerch Strait, connecting the Taman Peninsula in Russia with the Kerch Peninsula in Crimea. This massive infrastructure project consists of 2 parallel bridges, a 16.9 km long road bridge and an 18.1 km long railway bridge. Together they form a double parallel box girder bridge with a truss arch span. A box girder bridge uses hollow box-shaped structures, usually made of steel or concrete, to form its main beams. Although the box girder bridge is normally a form of beam bridge, box girders may also be used on cable-stayed and other bridges. The Crimean Bridge features a truss arch span with its longest section measuring 227 meters, and it provides a clearance of 35 meters beneath for ships passing through the strait. The road bridge carries 4 lanes of traffic, while the railway bridge accommodates 2 tracks for trains. Construction began in 2016, with the road bridge completed in 2018 and the railway bridge finished in 2019. The Landwasser Viaduct is ranked 5th on our list and stands as one of the most iconic railway bridges in the world. A viaduct is a specific type of bridge made up of a series of arches, piers, or columns designed to support a long elevated railway or road. Typically, a viaduct connects 2 points of roughly equal elevation, allowing a direct overpass across wide valleys, rivers, roads, or other low-lying obstacles. The Landwasser Viaduct is a single-track, 6-arched limestone structure located between Schmitten and Filisur in the canton of Graubünden in Switzerland. It spans the Landwasser River and is a signature structure of the World Heritage-listed Albula Railway, owned and operated by the Rhaetian Railway. Designed by Alexander Akeitos, the viaduct was built between 1901 and 1902. Standing at 65 meters high and stretching 142 meters long, it features a highly pronounced curve with a tight radius of 100 meters, which adds to its appearance. The viaduct is supported by 6 arches, each 20 meters wide, resting on 5 tall limestone pillars. Its masonry consists of roughly 9,200 cubic meters of dolomitic limestone. What makes the Landwasser Viaduct particularly impressive is its southeastern abutment, which leads directly into the 216-meter Landwasser Tunnel. The tunnel's entrance is carved into a vertical rock face, seamlessly aligned with the viaduct. This perfect integration of bridge and tunnel was a significant architectural and engineering challenge during its time. The Yavuz Sultan Selim Bridge in Istanbul, also known as the Third Bosphorus Bridge, is ranked at number 4. Construction began in 2013, and the bridge officially opened to traffic in 2016. Designed by Swiss engineer Jean-François Klein and French structural engineer Michel Virlojoux, it's a hybrid cable-stayed suspension bridge, a rare and fascinating type of design. Besides Istanbul, this hybrid design has been used in iconic structures like the Brooklyn Bridge in New York City and the Krishna River Bridge in India. Now for the numbers. This bridge is 58.4 meters wide, making it one of the widest suspension bridges in the world. It stretches an incredible 2,164 meters in total length, with a main span of 1,408 meters. At 322 meters tall, it's also the 5th tallest bridge in the world of any type. This bridge has 4 motorway lanes and 2 railway tracks, making it a crucial part of Istanbul's transport network. At number 3 we have the Öresund Bridge, a stunning combined railway and motorway bridge that links Denmark and Sweden across the Öresund Strait. This iconic structure is one of Europe's longest bridges to integrate both road and rail traffic in a single design. Stretching 7.9 kilometers from the Swedish coast to the artificial island of Pebberholm in the middle of the strait, the crossing is completed by the Drogden Tunnel, a 4.0-kilometer underwater connection to the Danish island of Amager. Why was a tunnel included? The decision to dig part of the crossing rather than extending the bridge was strategic. It avoids interference with air traffic from the nearby Copenhagen airport, ensures an unobstructed passage for ships in any weather, and eliminates issues caused by ice flows during harsh winters. Construction began in 1995 and the bridge officially opened in 2000. The Öresund Bridge supports 2 railway tracks beneath 4 road lanes, all carried by a horizontal girder. This girder is supported by concrete piers spaced every 140 meters along the bridge. The central section features a cable-stayed design with a main span of 491 meters, supported by 2 pairs of 204-meter-tall towers. These towers provide 57 meters of clearance for shipping, although most vessels prefer to use the unobstructed Drogden Strait above the tunnel. At number 2 we have the Gölcz Viaduct, a masterpiece of 19th-century engineering and the largest brick-built bridge in the world. Located in the Free State of Saxony, this incredible structure spans the Gölcz River valley between the districts of Milau and Nechkau. It was constructed as part of the railway line connecting Saxony with Bavaria, and when it was built, it was not only the largest brick bridge but also the tallest railway bridge in the world. Construction began with the laying of the first stone in 1846. The project encountered significant challenges, leading to a single revision of the original plans. For example, the foundation on which the bridge was to be built proved less stable than initially assumed. Chief Engineer Robert Woolk addressed this issue by replacing several smaller arches in the middle with one large central arch. This modification not only solved the structural problem but also added to the visual impact of the viaduct. The project was completed in 1851, resulting in an iconic structure made from an astonishing 26 million bricks. The Gölcz Viaduct measures 574 meters in length and 23 meters wide at its base, narrowing to 9 meters at the top. It reaches an impressive height of 78 meters, dominating the valley below. The viaduct consists of 98 arches spread across 4 levels, with the top level comprising 29 arches, the widest of which spans 31 meters. Brick production for the viaduct was an enormous undertaking. Nearly 20 brickyards along the railway line produced 50,000 bricks daily to meet the demands of the construction. The 4th bridge is the top spot on our list. This iconic cantilever railway bridge spans the Firth of Forth in eastern Scotland, located 14 kilometers west of central Edinburgh. Completed in 1890, the bridge is celebrated as a symbol of Scotland and was voted Scotland's greatest man-made wonder in 2016. It is also a UNESCO World Heritage Site. Designed by English engineers Sir John Fowler and Sir Benjamin Baker, it remains one of the most impressive railway bridges ever built. A cantilever bridge is a type of bridge that uses cantilever beams to support its structure. These beams are anchored at only one end and extend outward, supporting the central girder. This design effectively balances the forces of tension and compression, making it suitable for spanning large distances without requiring extensive support piers. The Forth Bridge illustrates this principle perfectly, with its massive cantilever arms supporting a light central truss. This concept was famously demonstrated in 1887 by Japanese engineer Kaiichi Watanabe, who was shown suspended between Fowler and Baker to visually explain the forces at play. The Forth Bridge spans 2,467 meters in total length, carrying a double railway track elevated 45.7 meters above the water at high tide. It features two main spans of 518 meters, two side spans of 207 meters, and 15 approach spans of 51 meters each. Each main span consists of two 207-meter cantilever arms that support a central truss measuring 107 meters. The bridge's superstructure weighs a staggering 51,324 tons, held together by an incredible 6.5 million rivets. Its three massive four-tower cantilever structures rise 110 meters above their granite piers, creating an imposing yet elegant design. Construction of the bridge began in 1882 and was completed in 1890, with the bridge officially opened by the Duke of Rothesay, the future King Edward VII. The Forth Bridge carries the Edinburgh-Aberdeen railway line and serves as both a functional piece of infrastructure and a lasting symbol of engineering brilliance. And that's the end of our list. Thank you so much for watching and joining us on this journey through some of the most impressive railway bridges in the world. We'd love to hear your thoughts. Do you agree with our ranking? Is there a bridge you think should have made the list? Let us know in the comments below. Also, if you think any of these bridges deserve a dedicated video where we dive deeper into their history and engineering, feel free to tell us which one. Your input helps us create the content you love. Thanks again for watching, and we'll see you in the next video.